Okay, guys. Bismillah ar-Rahman rahim. Good afternoon. So today we're going to discuss about the stack in data structure and algorithm. So we have already basic concepts about the stack. That is, stack is the type of data structure used to store the data inside of LIFO, last in and first out. The element which is inserted as the last will be removed as the first. So we will discuss a lot of two basic operations which can be carried out on the stack. We call them push and pop. Okay. So basically, push is the function used to insert the data, and pop is the function used to remove the data. First, I think we have discussed this one already, right? No. Okay. So stack basically is also called LIFO, list of elements, which is an element may be added or deleted from. So if we talk about this stack, so it could be stack of coins, it could be stack of books, or it could be the stack of memories. So let's suppose this is the memory stack and we are going to insert the data. So this is the end point, we call it top. But if we talk about the queue, in queue we have two endpoints, right? So we call it queue. So here is the front point, and this one is the rear. So data is always inserted from the rear point in queue. I'm talking about the queue, and data is removed from the front. So if we will insert, this could be the 10, this could be 20, 30, 40, and so on. So if you will remove the first element which we inserted, that will be removed the first in the queue. But in the stack, it is inverse. So let's suppose we have empty stack. Yes, get in. So if you can see here, this is about stack. So at this top, this stack is null. Remember one thing, when stack is null, the top is -1. Because this shows that there is no any single value in this stack. So we always push the value down in this stack. That's why we call it push function. Means we push value down in this stack. So if I want to insert the first value 10, it will be stored here. Okay, so it can be at index 0. So after inserting the value of top will be increased by 1. So it could be +1, so it will be 0. So your top is pointing here now to this one. Okay. So remember, when new value is added, that will be your top value. So in this current situation, the top is 10. This is the top value. If I want to insert the new value, that is 20, that is at index 1. Now, because this is on the top will be changed. Increase value of top by 1, 0 plus 1, 1. Now, top will point to this value. Okay? So again, if you want to insert the new value, that will be stored on the top. So top will be changed. Increase the value of top by 1. It will be 2. So now top will point to this one. So remember, in stack, when we insert the new value, the value of top will be increased by 1 in array representations. Okay? But when you remove the value in the stack, the value of top will be decreased by 1. For example, at this current situation, the top is 2. Let's suppose I want to remove the value. Which value will be removed first? The value which we inserted in the last, that will be removed at the first. So on the last 30 insert किया थे. Now if you will remove the 30 20 first you need to remove. After removing, decrease the value by 1, so it will be 2 minus 1, 1. Now your top will point to this value. After removing this one, the top will 0. So it means top is pointing to this one. After removing the 10, top will become minus 1. When top is minus 1, this represents the stack is null. There is no any value in the stack, right? So, in cube we have 2 endpoints, but in stack we have 1. That is the top. From this top we can insert or we can remove the value. So anything removed from the stack is taken from the top of the stack. If you want to remove, you need to take it from the top. If you want to insert, you need to insert on the top. So it is all about the top. Okay? So things are removed in order from which they were inserted. They were last in, first out. So the other names, pulse or the push down. Stack is also known as stack is also known as pulse, or we can also say them push down. These are two different names, pulse or push down. So if you can see here the example of a stack. So the first one you can say the stack of coins. Exactly the second one the stack of books. And computer stack, the memory of the computer, right? Simply, if we can put the books in the computer memory, the first book, then second, then third, the book which is inserted on the top, that will be removed first. We're already in this one. So don't be confused. You can represent the state memory in vertical or horizontal, doesn't matter. Okay, so if you can see here, we have 3 formats of the state. One is in horizontal, the 2 are vertical. First the data is from there, the top and the bottom, doesn't matter. Main thing is here from the starting from the 0 and so on. So आप वहाँ से 0 से करें या नीचे से 0 से करें, doesn't matter. Okay. So let's suppose this situation A, B, C, D. The total, how many data are there? 4 elements. That's why we have count is equal to 4. Even though size is maybe n, it can be 100, it can be 50. The value of n can be 100 or 50. We don't know. And what is the value of top in this example? 3. Because the last value we inserted is the double D. If we want to insert the new value, EE, that will be inserted at index 4. Okay, the value of top will become 4. And the count will be 5. Okay? I think this one is clear. So, as we discussed that there are 2 basic operations. The push and pop. Maybe you have experience when you go in some kind of the offices or the shopping malls, it is always mentioned push. Push what does means? You need to push inside, but sometimes we need to pull out. जब हमें पता नहीं होता तो क्या करते हैं फिर उसको खींचते रहते हैं. Okay? So push का मतलब we need to push down the values, we need to insert the values. The other operation is the pop, remove the values from the stack. So if you can see this graphical representation of the push and pop functions, the first figure you can see on the left side, top left, what do you see there? It is empty, right? The stack is empty. You can't see any value. So after performing push 2 means we want to insert 2 in the stack. So first value is 2. So push is pointing to 2. Oh, so top is pointing to 2. Now this 2 is on top. Now we want to push 5. Means we want to insert 5. When after inserting 5, your top will change. It will point to 5. Then push 7. After inserting the new value 7, the top will change, and so on. Now we want to perform the pop operation in the last row. We're performing the pop. So top, which value will be removed? Which was in the top? Top pe kya thi? The first one was on the top, right? So after performing the pop operation, the one has been removed. Then we performed again push 21. Insert 21 new value that has been inserted after 7. Then again, if you want to perform pop, 21 will be removed because that was the last value which was inserted. So it is the definition of state, the last in, first takeout. So again, the pop 7, and we again perform pop 5 and so on. Another example, pictorial view of the push function. So in the left side you can see this is our current situation of this stack. We can find that there are 2 elements in this stack, right? In the left side. So top is representing the value which is on the top. After performing a push, the new data is inserted and you can see the change in the right side. The new data which is in the shade format, in blue shade, that is inserted on the top. So this is how push can be performed, right? Similarly, you can perform the pop. This is your original, the left side figure shows that this is your original stack. Yeah, how many values are there of the elements? Maybe 3 elements are there. Huh? So after performing pop, the top most data has been removed, and the right side you can see the updated stack. So now the remaining 2 elements are there. Okay, this game is very much interesting. This is an application or an example of the stack. The Tower of Herod, the stack based applications. So let's discuss कि इसमें होता है क्या है. So if you can see here in the bottom, there are 3 poles, A, B, and C. Can you see that? At the bottom, you can see that there are 3 poles, A, B, and C. So a set of disks is on the pole A. So there are 3 disks on the pole A. Okay? So the disk on the first pole, the disk of different size, the smallest disk is at the top. Different size की disk है, मगर smallest disk count भी top पे. Can you see that? पहले larger है, then उससे छोटा है, then smallest one on the top. I'm talking about this one. So, what is your goal? Our basic goal or object is to move all this from left pole to the right pole. In other terms, we can say that our goal is that we move all this from pole A to pole C. So how you will move the disk? You have different ways. बस disk उठाएं और वहाँ पे रखते हैं. The series will maybe change. आप पहले कौन सी disk उठाएंगे smallest, take smallest out and put in the seed. Then second larger, its sequence will change. Yes. Yes. So we have different conditions. So conditions, only one disk may be removed at the time. You cannot just take all the disk, 3, and put on the pole C. No, you cannot. You have terms and conditions. You have to follow the rules. Rule number 1, take one by one. Number 2, this can be placed either on an empty pole or top of a larger disk. Rule number 2, या तो डिस्क आप एम्प्टी पोल पे रखेंगे या बड़े डिस्क के ऊपर छोटी डिस्क आनी चाहिए. You cannot place the larger disk on the smaller disk, right? You cannot do that. These are the 2 rules you have to follow. So now let's start our goal. So you can see here, in step 1 on the top, left top, is the initial step. This is our original. Now our task is to move all this from pole A to pole C. But we have to follow two conditions, don't forget. या तो आपको डिस्क एम्प्टी पोल पे रखनी है या लार्जर डिस्क के ऊपर छोटी रखनी है. गॉट इट? ये दो रूल है. सो आफ्टर मूविंग नंबर स्टेप 1 में सेकंड देखें, वी मूव सिमालेस टू सी. नाउ राइट साइड द टॉप वन. अब क्या करें? वी मूव येलो वन एंड प्लेस ऑन द बी. रूल फॉलो कर रहे हैं. Now we need to place this blue in the C, right? Because this one is the larger, so ये सबसे नीचे आएगी. So we need to take out the disk from pole C to place on the B. कोई इश्यू रूल को वायोलेट किया हमने? नहीं किया. बड़ी के ऊपर छोटी. So C के पास छोटी थी, that's why we place on B. So now the C pole is empty. You can easily take the disk from pole A and place to the pole C. Okay? Then again, आपको ये येलो डिस्क चाहिए ब्लू के ऊपर रखने के लिए. You cannot put this green one, right? So that's why we take the green disk, the smallest, from pole B and place on the pole A. Then again, top right, if you can see that, now we take the disk from pole B and place on pole C. Now you can easily move the smaller disk. This is how you can play the game. It was very much easy to take all the disk and place on the C, right? But no, you can't. You have to follow the rules. One disk at a time. You must place the smallest on the larger one. So this one is one kind of the application of the stack. So stack is also represented in two ways, using array or linked list. As we have discussed that Q can be represented using array or linked list. So let's talk how stack is represented in linked list. So in simple format, this is a linked list, right? You have nodes, data is there, addresses are there. But when we declare the top, so top make us distinguish or make us clear that this one is stack, not linked list. In linked list, we don't have top, right? When you put the top as a variable, now you are bound that this is a stack. So if you can see here, this is the first value we have inserted, then B value we have inserted, then C, then D. The last value we inserted, that is D. So now your top is pointing to D. D की address क्या है? 3901. So top is equal to 3901. And the count is 4. How many items are there? 4. So this is stack representation using linked list. If you want to insert the E, where you will insert? If you want to insert, yes. If you want to insert a new data, तो कहाँ पे insert करेंगे? After D. When you will insert the new data after D, the value of top will change. Let's have a look. This is our stack. So this is our head or start. This is pointing to your first node. Okay? So let's suppose this is your A, this is your B data, C. So it's the address of node can be 001, 002, 003. So 001 is here. So your top, what will be the top? Yes, it will be 003. So your top will point to this one because this is the last data we inserted in this stack. So count means total items or the values in stack 1, 2, 3. Okay. Now, if I want to insert a new item in this stack, where I need to insert? Here or here? Yes, this is the top, so new value will be inserted again on the top. So if I want to insert here, this is my new item. Let's suppose D, it has been connected. The address of this node can be 0, 0. After inserting, the top will change. So now your top will be 0, 0, 4. So it will not point to this one, but it will point to 0, 0, 4. Okay, this is null. Okay, so your count will be increased by 1. This is how it happens. Got it? Now if you can see here, same push operations we have discussed here is represented here. So we are going to push a new node. The new node has been added after the G, and the value of top has been changed, and the total count has been changed. Right? Is it clear? Guys, is it clear? Yes or no? Now push, okay? Let's suppose now I want to perform push operations. So this node will be removed, okay? After removing this node, your top will change. Now the top will become 0, 0 because this is on the top node. So your top will point again to this one. Okay, this is push and pop. I think this one is very much easy. So the next one is the array representation. Array representation is very much easy as compared to the linked list. Majority or most of the people, they are very much, you can say, feel easy to work with the array representations. Okay? So even though we people also, if I say write a program, it's up to you using array or linked list, which you will select. Array, right? Why? Because it is easy. So in algorithm of pushing and popping in items from the stack, we can consider a linear array as a stack, variable top, and the stack size. When you have algorithm for push, we need few variables: array, top, and size of array. Okay. So if you can see this one, you need to understand few conditions when you work with array representation of the stack. Condition number 1, the condition top is equal to -1 or null. Okay, let's suppose again, I need to, this one. This is array, now I'm working with the array representation of the stack, okay? This is our array. We can insert the number of values in our array. This is at next 0, this is 1, 2, and 3. So this is my top variable, 1, 2, 3, 4. I can say that size is 1, 2, 3, 4. This stack will hold four values, right? That's why size is 4. So what is top here? Top is -1 because stack is null. When stack is null, the top is -1. Or we can say that when top is -1, remember that the stack is null. Condition number 2, the condition top is equal to 8. Why it is 8? Because we are considering this example. But what if you consider here this example? Let's suppose your top is 3. If your top is 3, what does this mean? Means there are values in this stack, the top is representing here and it is full. Is it full now? क्योंकि जब भी आपका टॉप 3 पे होगा और साइज आपकी 4 है, इसका मतलब है इस एग्जांपल में ये आपका स्टैक फुल है. उस एग्जांपल में if your top is 8, this means your stack is full. Your stack is full. Or S will be overflow if top is equal to 8 and push. Now let's suppose I want to perform here push 5. Will it be performed? Can I push the new value in this one? Why? The stack is full. I don't have its space, right? So similarly, it said that when its top is 8, and again you want to perform push, then you will not be able to perform the push because it is full. Huh? No, let's suppose it is full already. We're considering it is full. At this situation, the top is 2. But अगर सारा डेटा इंसर्ट हो जाता है, टॉप 1 तक पहुंच जाता है, तो it is full. So now, it will be underflow if top is equal to -1, and you want to perform top. Let's suppose so your top is -1, right? Minus means it is empty, but I want to perform pop. Can I perform pop? No, because pop function is used to remove the value from the stack. I don't have value to remove. That's why it is underflow. We call this situation as a underflow. Clear? What is it? So our representation, if you can see here, the first value is B, then C, then D, then E. So the top is 3. Okay. The total size is stack size minus. So why we write here size minus 1? So you need to see here. Let's suppose this is my new stack. Okay. So what is size here? साइज क्या है यहाँ पे? 1 2 3 4 5. साइज 5 है? गुड. साइज 5 है. तो ये वैल्यू ये क्या सी होगी? इफ आई राइट दिस वन साइज -1, इज इट ओके? द लास्ट वैल्यू ये इंडेक्स साइज -1 है. द लास्ट इंडेक्स साइज क्या है? -1 कर रहे हैं. दैट्स व्हाई इट्स रिटन हियर स्टेक साइज -1. ये 10 हो सकती है, तो ये 0 से स्टार्ट होगी तो नोट पर चलेगी. ये ना इसमें नहीं, आई डोंट थिंक सो इट इज मच डिफिकल्ट. देखिए मेन चीज है स्टेक की साइज बेटा. सो इफ यू कैन सी हियर, यहाँ पे कितनी साइज है स्टेक की? 5. तो ये इंडेक्स समटाइम्स हमें पता नहीं होता कि ये कहां तक पहुंचेगी. 1000 तक होगी या 2 लाख, वी डोंट नो. तो हम क्या लिख कर लेते हैं? तो साइज -1. तो ये जो लास्ट वाला इंडेक्स है वो साइज -1 होगा, क्योंकि इफ साइज इज 5, ये 0 से स्टार्ट होगी तो ये अब हमारा 4 होगा. तो 5 -1 4. दैट्स व्हाई वी राइट हियर साइज -1. ओके, बिकॉज इट स्टार्ट फ्रॉम 0. सो इफ यू कैन सी हियर, when it is full, in this situation stack is full, the middle one, so the top is equal to stack size -1, right? yahan pe if I write here 1 2 3 4 5, so my top is, what is my top? I can write here size -1, so it will become 4. Correct? So when top is size -1, it is full. Or when top is -1, it's empty. You can see. Then from tomorrow we will start a discussion of algorithm, how push and pop works. Then we will start to implement our work here and here. Okay? So if you can see here, this is your stack again. We're performing the push operation. So your top, what is top? What will be the top here? Top in this situation, what is top? Top क्या है यहाँ पे? भाई टॉप वहां पे जो आपका लास्ट डेटा इंसर्ट होता है उसको पॉइंट करता है. So your type is top is 4, and count how many values are there. 1, 2, 3, 4, 5. Okay? So again, if you want to perform the push operation, you can say that 15 has been added in this state. So your top will be increased by 1. It will become 5 and count will be increased by 1. 6 elements. So this one is, I think, very much easier. Okay. So this is an algorithm. Hopefully we'll discuss tomorrow. Okay.